All right, today we're tackling one of the most mind-bending ideas in all of science, the possibility of extra dimensions. I mean, are we talking science fiction here? Or could these unseen worlds actually be the key to understanding reality itself? Okay, so to get our heads around this, we have to start with the single biggest problem in physics today. You see, for the last 100 years or so, our whole picture of the universe has been built on this fundamental contradiction. We've got two theories that work incredibly well on their own, but they just refuse to play nice together. Yeah, it's a huge issue. We have these two pillars of modern physics, and they describe our universe with unbelievable accuracy, but they just don't agree. They're like two different rule books for reality. So on one side, you've got Einstein's general relativity. It's this beautiful, elegant theory of gravity that explains everything on the grand cosmic scale. Planets, galaxies, the whole shebang. And then on the other side, you have the wild and wacky rules of quantum mechanics. This theory describes the chaotic dance of the tiniest particles that make up, well, everything. And here's the kicker. Both of them have been tested like crazy, and they work perfectly, but only in their own sandbox. But what happens when you need both theories at the same time? Like, say you want to figure out what's going on deep inside a black hole, or right at the moment of the Big Bang. Well, that's when things get really weird. You try to combine their math, and the equations just completely break down. They start spitting out total nonsense, infinite energies, infinite probabilities. Physicists have a great name for it: disastrous infinities. And that's a giant red flag telling us that something is seriously missing from our understanding. Now, this problem has had physicists scratching their heads for a century. But believe it or not, a potential solution, a really radical one, was proposed way back in the 1920s. The idea was, what if the problem isn't with the theories themselves? What if the problem is the stage they're performing on? What if there's more to space than meets the eye? You know, this whole idea of extra dimensions isn't some newfangled thing. It's actually been evolving for over a century. It all started back in 1921 with Theodor Kaluza. He was playing with Einstein's equations and realized that if you just added one more spatial dimension, a fourth one, the laws of electromagnetism just popped right out of the math. It was stunning. A few years later, Oscar Klein took it a step further and suggested, hey, maybe this dimension is real. It's just curled up super, super tiny. And fast forward to today, that very same concept is at the heart of things like string theory, which proposes not just one, but maybe 9 or 10 spatial dimensions. But even the pioneers knew this was a huge leap. You can see it in his quote from Oscar Klein himself. He was pretty humble about it, basically saying, look, this is a really cool idea, but we need future experiments to tell us if it's actually real. Still, it held this incredible promise of explaining all the universe's rules with a single unified theory. Okay, so that leads to the obvious question, right? If these extra dimensions are real, where the heck are they? Why do we only experience 3 dimensions of space? Up, down, left, right, forward, backward. Well, the proposed answer is a concept called compactification. Compactification is basically the idea that these other dimensions are hidden from us because they're unimaginably small. They're not somewhere else. They're right here, at every single point in space around us, but they're just curled up into a tiny little shape, way too small for us to ever notice or move through. The best way to think about it is with an analogy. Imagine a long rope or a washing line. From really far away, it just looks like a one-dimensional line, right? You can only move forward or backward along it. But if you were a tiny ant living on that rope, your reality would be totally different. For you, there's a whole other dimension to explore, the tiny circle you can walk around. Our universe could be just like that. 3 big, obvious dimensions that we can see, and a bunch of other tiny, curled-up ones that are only accessible at the smallest scale. And this gives us a brilliant way to picture how a higher dimensional object might appear in our world. Think about a 2D universe, like the book Flatland. If a 3D object, like a sphere, were to pass through their flat world, what would they see? They wouldn't see a sphere. They'd see a single point just appear out of nowhere. That point would grow into a circle, get bigger and bigger, then shrink back down to a point and just vanish. What they're seeing is just a 2-dimensional slice of a 3-dimensional reality. And maybe that's what we're seeing too. All right, so this is all great food for thought, but is it actual science? You bet. Physicists aren't just doodling this on blackboards, they are actively hunting for evidence. And the main hunting ground is the Large Hadron Collider at CERN. The whole idea is to smash particles together with so much energy that you might just shake something loose from one of these hidden dimensions. So what are they looking for exactly? Well, there are a few key signatures they're hoping to spot. One is finding heavier echoes of particles we already know. Think of it like a particle that's not just moving in our dimensions, but also has a little bit of momentum in a tiny, curled-up dimension, which makes it look heavier to us. Another huge one is looking for energy that just seems to disappear after a collision. The theory is that a graviton, the particle that carries gravity, might have literally escaped, leaking out into those extra dimensions where other particles can't go. And I can't overstate this. Finding real, hard evidence for any of these things would be an absolute game changer. It would be the first concrete proof that the world we see and touch every day is not the whole story. It would completely rewrite our fundamental model of the universe. Because really, this whole quest isn't just some mathematical curiosity. If we could confirm extra dimensions exist, it could finally solve some of the deepest, most stubborn mysteries we have about the cosmos. It could give us that unified picture of reality physicists have been dreaming of for a century. Take gravity, for instance. Have you ever wondered why it's so incredibly weak compared to the other forces? I mean, a tiny little refrigerator magnet can pick up a paperclip, defeating the gravitational pull of the entire planet Earth. That's bizarre. Well, one of the leading ideas from string theory offers an amazing explanation. It suggests that our universe might be like a three-dimensional membrane, a brain, floating in a higher dimensional space. And while most forces are stuck to our brain, gravity isn't. It can spread out or leak into all those extra dimensions, which would dilute its strength and make it seem so weak to us. And that leaves us with this final, really mind-bending thought. This whole search for extra dimensions forces us to ask a profound question. What if the universe we experience, with all its stars, planets, and people, is just a slice, a kind of three-dimensional shadow of a much larger, more complex, and fundamentally unseen cosmos? The answer could be right there, hidden in plain sight, just on a scale too small for us to ever see.